Good morning, sir. My name is Panchigala. My student ID is 20002020030113. In this question, temperature varies as given function, and a particle moves with respect to time as given parametric equations. And we have to find the temperatures at point given point and with respect to Celsius per meter and in terms of Celsius per second. Now in question A, we have to compute directional derivative of t in the direction of particle's velocity vector. And in question 2, we have to compute directional derivative of t with respect to t. But this is the same as the dot product of gradient t and the particle's velocity vector at t. Here, a given point state that our particle is at a point p when time equal to 2. Now, we have we will calculate delta t at point p, and this is as follow. And now we have the position of particle, and from that we calculated velocity vector of it at point p, or we can say that time equal to 2. And with the use of that, I derive unit vector in the direction of vector velocity, and then calculate the directional derivative of t, and it will come as 78.02. Now, the rate of change of temperature at t uh, in terms of Celsius per second is as follows, as is come out to be 7036. So that's the first question. Now, in this question, a particle traveling in a straight line with a constant velocity I plus j minus 5k and passes through a given point 0, 0, 30 and hits the surface z equal to 2x square plus 3y square. Now, the particle rotates off the surface and we have to find the what is the velocity of particle after the relocate. And we have given some properties is that angle of reflection being equal to the angle of incidence, and we have do not lose any speed. Now, I write some basic property from the questions, and find the point on the surface so we can uh, create a normal surface on that point. We have to write equation of line which cuts the given surface. So the equation of line is given as follow: x equal to k, y equal to k, and z equal to 30 minus 5k. And it cuts the surface, so we can put all the values in equation of surface. So we get the value of k is equal to 2 and minus 3. But as you all know that particle always go forward, not going backward. So that's why we only take the value of k is equal to 2, not minus 3. So from above, we get the value of point on the surface is 2, 2, 20. Now, suppose that the velocity of particle after rocket is ai plus bj plus ck, and v1 and v2 intersect at point P. Now, for finding the reflected ray, we have, we have to use the basic rules of reflection. And we also given is that incident ray and normal of the plane and the angle between the reflected ray and normal of the plane is equal. So theta 1 is equal to theta 2. And moreover, the normal of the plane is equal to the gradient of f at p, because the plane at p on the surface, f does the reoccurrence, and we know that the gradient of surface is perpendicular to the level curve of that surface. So the gradient is given as follow, and at point P, the value of gradient is 8i plus 12j minus k cap. And we see that there is no speed of loss. So modulus of v1 is equal to modulus of v2. Now, as I told before, the angle of incident is equal to angle of reflection, meaning that theta 1 is equal to theta 2. And so we can take both side cos value of it. So we can take dot product on both sides, as you all know. So v1 dot gradient f is equal to v2 into gradient of f at t. Uh, so we get one equation in ABC. Now we all know that when particle is on the surface, incident ray, normal, and reflected ray are always in the same plane. So means its sign component, both sign component are equals. So from using this property, we get three equations like this, and using all the four equations, we get the value of ABC, and there's the answer of our question, that particle velocity after relocate is uh, minus 1 upon 209 multiplicand into 1 191i plus 391j plus 995kk. Now, in this question, estimating the volume of cylinder with the radius is with radius 2 meter and height 3 meter, we have to measure the accuracy in radius and height so that error in volume will not exceed zero point 0.1 meter cube. And we have given is also that dr is equal to dh. So for with the following information, we write the equation of volume of cylinder is equal to pi r square, and then to find following details, we differentiate this equation, so we get dv equal to 2 pi rh into dr plus pi r square into dh, and we also given is that dr is equal to dh, and value of r is equal to 2 and value of h is equal to 3. Put put all the information in above equation, so we get the value of dr and dh is equal to near equal to 0.002 meters. So we have to measure the radius and height of the cylinder with the accuracy of 0.002 meters, so that the error in the volume estimate will not exceed zero point 0.1 meter cube. Thank you. In this question, we are given this equation 1 upon r equal to 1 upon r1 plus 1 upon r2. From this equation, we have to show that dr is equal to r upon r1 raised r1 square into dr plus dr1 plus r upon r2 square into dr2. And again, second question is if r1 is 100 ohm and r2 is 400 ohm, but there is always some variation in manufacturing resistance received by your firm will provide not as this exit value. So we have to check uh, R will be more sensitive in variable of R1 and R2. And third question is if in, uh, in circuit like figure 1, we have to change R1 to 20 to 20.1 and R2 from 25 to 24.9 ohm. So what will change of a percentage in R? Now for first question, uh, in given equation we have to just differentiate the equation, so we will get the following equation, and simplify that we will get the uh, given equation, so that we have to prove. Question B, we have to find dr equal to c1 into dr1 plus c2 into dr2 equation, and with the help of c1 and c2 we can say that variation in r1 and r2, the uh, value of r will be sensitive. And here value of r1 is 100 ohm and value of r2 is 400 ohm. So with the help of that we can get the value of r, which is 80 ohm, and put all of this value in equation 1. We will get the equation of dr in terms of dr1 into dr2. Here we can uh, clearly show that c1 is value of c1 is greater than value of c2. uh, so r is more sensitive towards the r1. uh, let's try this with one example like that. Here they will we only change in R1 by zero point 0.1 ohm. So dr is equal to zero point 0.1 ohm and dr is equal to 0 ohm. So change in R is equal to 0.064 ohm. Now we do the same process for R2. So dr1 is equal to 0 ohm and dr2 is equal to zero point 0.1 ohm. So we will get the change in dr is equal to 0.00256 ohm. So we here we clearly said that change in R1 is greater than change in R2. Now the question 3. Here R1 value of R1 is 20 ohm and value of R2 is 25 ohm. So we will get the value of R using uh, first equation. The value of R is equal to 100 by 9 ohm. Uh, now we change the the value of R1 and R2. So we will get dr1 is equal to zero point 0.1 ohm and dr2 is equal to minus zero point 0.1 ohm, and put all of this value in equation number 1. We will get dr is equal to 1 upon 90 ohm, and for relative change in r, the equation is dr upon r into 100. So with the help of this function we will get change in percentage change is equal to zero point 0.1 percentage. So that's the answer of this question. Thank you. Now, a space probe in the shape of ellipsoid, which equation is 4x square plus y square plus 4z square equal to 16, enters Earth's atmosphere and surface begins to heat. After 1 hour, the temperature on the surface of probe is given by T of x comma y comma z is equal to 4x square plus 4yz minus 16z plus 6,600, and we have to find the hottest point on the probe surface. To find the hottest point on the probe surface, we have to maximize the T subject to constraint 4x square plus y square plus 4z square is equal to 16. Now suppose f is equal to 4x square plus y square plus 4z square is minus 16 is equal to 0. Now apply the method of Lagrange to find x, y, z and L such that delta T is equal to lambda delta F, and F is equal to 0. Now delta T and delta F are given follow, and using Lagrange equation we will get the following three equations. Uh, and now equation 4 implies that we have two possibilities. One possibility is that lambda is equal to 2, and second possibility x is equal to 0. Now considering first possibility, lambda is equal to 2, put the value of lambda in equation 5 and 6. So we will get the value of y and z is equal to minus 4 by 3, and put the value of y and z in equation 1. We will get value of s equal to plus or minus 4 by 3. So from here we will get 2 points, 4 by 3, comma minus 4 by 3, comma minus 4 by 3, and second point is minus 4 by 3, comma minus 4 by 3, comma minus 4 by 3. Now, considering second possibility is x equal to 0. So from here, comparing equation 5 and 6, uh, we will get equation y into y minus 4 is equal to 4z square, and put the value of equation in 1 and x equal to 0 in equation 1. We will get y is equal to 4, comma 4 and minus 2. And from our points, we will get the value of z is equal to 0 and plus or minus root 3. So from here, we will get 3 points. First is 0, comma 4, comma 0. Second is 0, comma minus 2, comma root 3. And third is 0, comma minus 2, comma minus root 3. So now we have 5 critical points. And putting all the points in temperature equation, we will get different values. And but at point 0, comma minus 2, comma minus root 3, we will get the highest temperature. So we can say that at point 0, comma minus 2, comma root 3 is the hottest point of the proof, and the temperature at that point is 641.57 units. Thank you. Now, in this question, I am the charge of erecting a radio from the newly discovered planet and minimize the interference. I want to place it where the magnetic field of the planet is weakest. And the final planet is spherical, and the radius of it is 6 unit. And based on the coordinate system was origin at the center of the planet. The strength of magnetic field is given by m equal to 6x minus y square plus xz plus 16. So we have to place a radius telescope and we have to find the point. Now, from the question, the planet equation is x square plus y square plus z square is equal to 36. And we have to find the minimum, the value of m subject to the constraint x square plus y square plus z square equal to 36. Now suppose f is equal to x square plus y square plus z square minus 36 is equal to 0. And now applying the Lagrange multiplier method to find x, y, z, um, such that delta m is equal to lambda delta f and f is equal to 0. So now we find the delta m and delta f uh, with equations. And now put both the equation in method of Lagrange, we get 3 equations. Now with this equation, equation number 5 so says that we have two possibilities. One is lambda is equal to -1 and second is y is equal to 0. Now considering first possibility lambda is equal to -1, we will get the value of z is equal to 2 and value of l is equal to -4. And then put the both value of xz in equation 1, we will get the value of phi is equal to plus or minus 4. So now we have 2 points. First one is -4, 4, 2, and the second one is -4, -4, 2. Now, considering the second possibilities where x is equal to 0, we have to compare the value of lambda from equation 4 and 6. So we will get the equation z into z plus 6 is equal to x square. Now put the equation 7 and y in equation 1. We will get the value of z equal to -6, 3. And from value of z, we will get the value of x is equal to 0 and plus or minus root 3. So from here, we get 3 points. First is 0, 0, -6. Second is 3 root 3, 0, 3. And third one is -3 root 3, 0, 3. So from above, we have total 5 critical points. And put all the points in equation of magnetic field, we will get different value. But at point minus 3 root 3 comma 0 comma 3, we will get the minimum magnetic field. So we can say that at point minus 3 root 3 comma 0 comma 3 is the place where we have to place the radio telescope, and and the value of the magnetic field at that point is 30.23 unit. Thank you. In this question, by using the Taylor's formula, we have to find out that in which term, in which measurement, given volume varies quickly. To find out that, first we list out the volume details and find the following requirements for the Taylor's theorem, and put all the things in Taylor's theorem, such like V R plus delta R, comma H plus delta H is equal to V of R comma H plus first partial derivative respect to V at R comma H plus 1 upon 2 factor into second PD second derivative of PD with respect to width of E at R comma H, and error term of V in E is equal to 1 upon 3 factorial. Third derivative of PDE of V at point R plus C, C delta R, comma H plus C delta H, where C is between 0 and 1. Now here V of R plus delta R, comma H plus delta is equal to as following, and as we put R is equal to 1.5 foot, and H is equal to 5,280 foot. Our volume equation become 11,880 pi plus 15,840 pi into delta R plus 2.25 pi into delta H plus 5,280 pi into delta R square plus 1.5 pi into delta R into delta H, and our error term become is equal to 1 by 6 into 6 pi into delta R square into delta H. So here we see clearly see that our error term is only depend on the change of R and H. So we can say that error is constant. From above equation, the value of phi will be more sensitive to variation in R, or we can say in diameter. To understand it, let's try one example. First, we only increase the value of R by 0.1 feet. So delta R is equal to 0.1 feet and delta is equal to 0 feet. So volume will become as following, and we do same thing for in height. So our delta R is equal to 0 feet and delta is equal to 0.1 feet. So our volume become as following. Here we clearly said see that when we increment radius, our volume become very large than when we increase the height. So here, so from that we can say that our volume are very sensitive to radius or diameter. Thank you. Now, in this question, we have to measure the change in I when we drop the voltage from 24 to 23 volts and resistance drop from 100 to 80 ohm. And we have to also measure that the I is in terms of more sensitive. So to calculate this question, we write some following things that are given in the questions, and write down the things that are we need in the Taylor's theorem. Now we are expanding the Taylor's theorem up to quadratic form and take the error in cubical forms that are given in the following. And now I at 24 plus delta V, comma 100 plus delta R is equal to I at 24, 100 plus derivative at first PD at of I at 24, 100 and 1 upon 2 factorial into secondary of PDA of I at 24, 100. So we will get 0.24 plus 0.01 into delta V minus 0.0024 into delta R minus 0.0001 into delta V into delta R plus 0.000048 into delta R square. And our error term becomes as the following. Now here error is changing in when we change in C. Now we change the voltage and resistance. So delta V is equal to -1 and delta R is equal to -20 ohm. So delta is equal to I of 24 plus delta V, 100 plus delta R minus I of 24, 100. So we will get change in I is equal to 0.0552 ohm ampere. And for from above, we get the maximum error is equal to 0.0052 ampere. Now, to check the value of I will be more sensitive to V or I, R. Let's try first example. When we do only change in voltage by 1 and don't change R, so delta is equal to 0. So our current will become 0.25 ampere. Now we only increase the value of R by 1 ohm and do not change the value of V. So delta is equal to 0 and delta is equal to 1. So our I becomes 0.237 ampere. Here we clearly see that when we increase voltage, the current value of current will become very high with respect to when we change the R and when we change the R. So here we can say that I will be more sensitive to voltage V. Now, in this question, I'm going to find the surface area of the torus, whose equation is z square plus r minus b so, whole square is equal to a square, and 0 less than or equal to a less than or equal to b, and the r is equal to under square of x square plus y square. Now, in this graph, I say that this is radius b, and from center of ring, this is the radius a. So now we have to find the area surface area of this torus. Now this is a very complex surface area, we can say. To simplify it, we can use, we have to parameterize the given equation. So we get the coordinate system x, y, z is equal to be like this. So from that, a parametric equation of is become r of theta comma phi is equal to b plus a cos theta into cos phi I plus b plus a cos theta into sin phi j plus a sin theta k, where value of theta and phi is equal to belongs to 0 to 2 pi. So now surface area of the parametric equation is equal to region of phi, double integration of the region of theta comma phi, and modulus of r theta cross r phi into d theta into d phi. So now r theta is equal to given as follow and r phi is equal to given as follow. Then we take a cross product of r phi, r theta and r phi. So we will get this equation, and from that we find the modulus of r theta cross r phi, which is given as a into b plus a cos theta. So from that surface area of torus is given by this integral, and we will get the surface area of torus is equal to 4 pi square into AB. Now, in this question, we have to find the simplest closed curve C so that our integral, given integral, achieve its minimum value. Then we have to evaluate the integral. So, to starting this problem, we can think that we have to take a smallest possible simple closed curve. So we can first thought of it, we can take C as a was zero, but in this case, our integral value will become zero. But there is one possibility is like that integral's minimum value would be negative. So now taking this possibility and try to find the simplest closed curve C. Now applying the Green's theorem, we will get this equation. So from that, our integral value become as this. Here we know that the value of LHS is equal to value of RHS. So instead of finding the curve C, we can find the region D. Um, so value of integral become also same. So now thinking of region D as if our given this equation has all positive value, so that we can say that our all equation are above the surface. So the value of all the points on this region is positive. But if we choose that all the points on this equation are below the surface, so we can say that our whole region is negative. So now we find the volume of this. Our complete volume become negative as we want, and that's the minimum value. So from that, we can say that our equation x square plus 4y square minus 4 has all the negative values. So from that, x square plus 4y square minus 4 less than or equal to 0. So our region is become x square plus 4y square less than or equal to 4. So from that, our simplest closed curve is x square plus 4y square is equal to 4. So our simple closed curve is elliptic. So from that, we could find the value of integral by parameters x and y, and value of theta we can take 0 to 2 pi, and the value of this integral become minus 4 pi. There's the minimum value. Now, in this question, string musical instrument falls on the floor, and the string of the musical instrument is 1 and a is equal to 1. When the musical instrument hits the ground, the string was in rest position, hence where x0 is equal to 0. And the string was moving at the some velocity at impact, the time t is equal to 0. So y of t at x comma 0 is equal to minus 1. And we have to find the solution of y x comma t for the shape of the string at time t. And we also know that the both end of the string are hinged. So y of 0 comma t is equal to y of 1 comma t is equal to 0, because the length of a string L is equal to 1. So we describe all of the things that are given in the question. Then I try to write the solution of PD in a short manner, so we can complete that. So first we have to assume that solution y of x comma t is equal to multiple of two one variable function x of x into t of t. So we plug that in the equation. So we get x of x into t double dash of t is equal to x double s of x into t of t. So we can rewrite that in this form, and now we can separate that is equal writing. the constant by minus lambda. So now we go to ordinary differential equation. So we can solve by easily. So from above condition 0 y of 0 comma t is equal to 0 implies that x of 0 is equal to 0, and y of 1 comma t is equal to 0 also implies that x of 1 is equal to 0 there. Therefore, the only non-trivial solution for the first equation are when lambda is equal to n square pi. So the value of xn is equal to sine of n pi x, and the general solution for the t for this particular lambda n is equal to tn of x is equal to a into cos n pi t plus b into sin n pi t. And we have also given one condition is that y of x comma 0 is equal to 0. So x of x into t of 0 is equal to 0. That implies t of 0 is equal to 0. That turned out to be value of a is 0, and for our convenience we pick the value of b is equal to 1. So we get the equation of tn of 8 times t is equal to sine of n pi t. So from our original assumption, we get yn of xt is equal to sine n pi x into sine n pi t, and using for infinite series we can write that y of x comma t is equal to summation of n is equal to 1 to infinite bn into yn of x comma t, that are given follow. So from that we get the equation. Now we have also given condition is that yt of x comma 0 is equal to minus 1. So from that we could find the value of bn, and that are given as follows. And from that we get the value of bn is equal to minus 4 by n pi square if n is odd, and if n is even we get the value 0. So from above we get the value of solution of y of x comma t is equal to minus 4 upon pi square into sine pi x into sine pi t plus 1 upon 9 into sine 3 pi x into sine 3 pi t plus 1 upon 25 into sine 5 pi x into 5 sine 5 pi t plus up to infinite, which is the solution of our PDE. Now, in this question, we have to find the non-trivial solution of equation r minus 2p plus q is equal to 0 using the method of separation of variables. Now, to find the solution of given equation, we have to first assume the solution of z of x comma y is equal to is a multiple of one variable function x of x into y of x y. So from that we will get the value of p is equal to x dash into y, q is equal to x into y dash, and r is equal to x double dash into y. Now put all the three equations value in equation 1. We will get this following uh, uh, simplified form, and we can assume its value is equal to some constant k. So now solving the second equation minus y dash of y upon y of y is equal to k. Uh, by solving this, you will get equation y of y is equal to c into e raised to minus ky. Now solving the second equation, x double dash minus 2x dash upon x is equal to k. We will get following equation x double dash minus 2x dash minus kx is equal to 0. So now above equation is second order linear differential equation, and its auxiliary equation is m square minus 2m minus k is equal to 0. So from that the value of m is equal to 1 plus or minus under of 1 plus k. Now we have three scenario. If value of k is greater than minus 1, value of k is equal to 1, and value is less than minus 1. So now considering first case, value of k greater than minus 1. So we will get value of x is equal to a into e raised to 1 plus under root of 1 plus kx plus b into e raised to 1 minus under root of 1 plus k into x. So from that value of z is equal to a into e raised to 1 plus under root of 1 plus k into x plus b into e raised to 1 minus under root of 1 plus k into x into c into e raised to minus ky for some for all k. Now k value of k is equal to minus 1. So from here m value of m is equal to 1. So our equation become z of x comma y is equal to x into y is equal to a into e raised to x plus bx into e raised to x into c into e raised to minus y. Here value of k become minus 1. So e raised to plus y. Now considering thumb scenario is that value of k less than equal to minus 1. So from here value of m become 1 plus or minus under root of 1 plus k iota. So from here value of x become is equal to e raised to x into a cos under root of 1 plus k into x plus b sine of under root of 1 plus k into x. So from here value of z become e raised to x into uh, a cos under root of 1 plus kx plus b into sine of under root of 1 plus k x into c into e raised to minus ky. By simplifying this, we will get c into e raised to x minus ky into a cos under root of 1 plus kx plus b sine of under root of 1 plus kx. Now this is all from my side. Thank you.